Hi, welcome back. In this video, I'm going to show you how to understand which units you need to use for the ideal gas law. Remember, the ideal gas law is PV equals nRT, where P is pressure, V is volume, N is the number of moles, R is the ideal gas constant, and T is temperature. For pressure, there's quite a few different units that we know that we could use in chemistry class. We could use the atmosphere. We could use the kilopascal or the pascal. We could use millimeters of mercury. For volume, we could use liters or decimeters cubed or centimeters cubed or even meters cubed. Thankfully, for amount, we do have to use moles, and for temperature, we have to use Kelvin. So if you're ever given Celsius, you do have to change that to Kelvin by adding 273. But how do we decide which units for pressure and volume that we use in the ideal gas law? And the answer is in the ideal gas constant. If we rearranged our formula to solve for the ideal gas constant, PV equals nRT. If I want to get R by itself, R is equal to PV over NT. Our units for R are going to be units of pressure times volume over the units for amount and temperature. Amount and temperature, these two, will always be moles and Kelvin. So for amount and temperature, we have to use moles and we have to use Kelvin. But what about pressure and volume? And that is where we see that we have different ideal gas constant values that we can use. So the trick to knowing which unit you need for pressure and volume is in which ideal gas constant you choose to work with. So R is equal to 0.8214. You've probably seen that before. It's also equal to 8.314, and it's also equal to 62.4. And the only thing that's different about these ideal gas constants, because you're probably thinking it's a constant, shouldn't all of those values be the same? But we've calculated the constant in different units to make using the ideal gas law easier to work with. So the units for our first ideal constant are the normal units that we use in high school chemistry usually. So pressure will be in atmospheres times volume, which will be in liters, over moles times Kelvin. And another way to write this is atmospheres times liters per mole, which is you put like a -1, and per Kelvin with a -1. If we have 8.314 as our ideal gas constant, the units are joules per mole per Kelvin. And what you need to know about a joule is that it is equal to a pascal times meters cubed. So pressure would be in pascals and volume would be in meters cubed. So if you were given liters or decimeters cubed, you would divide by 1,000 to get into meters cubed. So if you're using the ideal gas constant 8.314, pressure needs to be in pascals, volume needs to be in meters cubed. If you're given kilopascals, you'll multiply by 1,000. If you're given liters or decimeters cubed, you'll divide by 1,000. And the last ideal constant, 62.4, the units are millimeters of mercury times liter per mole per Kelvin. And again, you can write this as millimeters of mercury times liters per mole per Kelvin. So pressure here has to be in millimeters of mercury, volume needs to be in liters, and then amount, of course, is in moles, and temperature is in Kelvin. So if you're given millimeters of mercury to work with as your pressure, you should choose to use this ideal gas constant. So the trick to knowing which units you need, because again, there are quite a lot of units for pressure and volume in chemistry class. The trick to knowing which unit you need is by looking at which ideal gas constant are you working with. If you want pressure in atmospheres, choose the first ideal constant. If you want pressure in pascals, you'll choose this ideal gas constant. And if you want pressure in millimeters of mercury, you would choose the last option. Just don't forget to double check your volume as well. If you're using 8.314, you need to change liters or decimeters cubed, or if you were given centimeters cubed, you would divide by 10 to the 6th. I do hope this was helpful. If you have any other questions about the ideal gas laws, go ahead and leave a comment. Make sure and check out other videos on my channel as well, especially if you're struggling with the gas laws. Thank you so much for stopping by.